Hi, we are in the reaction unit, and I would like to start this unit with single replacement reactions. So first of all, we're going to look at metals replacing other metals. And so an active metal can replace a less active metal that is in a solution. So here we have aluminum, and see the S by it, indicating that it's a solid. So that would just be like a piece of aluminum foil, and it's placed into a solution of copper 2 chloride. So that would be a pretty blue solution, and it would be aqueous. There we go. Okay, so whenever you see an element that's single, all by itself, I want you to start thinking, is this a single replacement reaction? It could be a synthesis reaction if it just combines with something. If it's oxygen, it could be a combustion reaction. But if it is single on one side, and then it combines with something on the product side, kicking something out that is now single on this side, on the product side, it's a single replacement. So let's see what happens. The aluminum comes in and it kicks out the metal, the copper. And so now copper comes out on the product side, and it's just copper metal. It would be making this coppery colored solid that would form in the bottom of your test tube. And then the aluminum takes the place of the copper and is now forming aluminum chloride, which is a clear solution. And so this is now in solution, so this is aqueous, and the copper again would be precipitating out as a solid. A couple of things I want you to notice. The one metal, aluminum, is completely replacing the other metal, and so that copper on the product side is out all by itself. So it has an oxidation number or a charge on this side of 0. See, the aluminum had a charge of 0 here. Now, when copper is here combined with the chlorine, it has a +2 charge, and so it's combined with 2 chlorines, and we call it copper 2 chloride. When the aluminum comes in and takes its place, notice aluminum takes the charge it always has, which is +3. And so we write aluminum chloride, AlCl3, like we should be writing since we just did that huge unit on writing formulas. All right, so it doesn't just come in and kick out the copper and take its place with 2 chlorines. You have to write the formula the right way. So aluminum, when it combines with something, has a +3 charge. And so if aluminum's +3, chlorine's -1, it's going to be AlCl3. But now you might be sitting there saying, but that's not balanced. And you're right. And so we're going to go back in and balance the reaction by putting in coefficients. So my chlorines aren't balanced, so it looks like I need to make it 6 chlorines by putting a coefficient of 2 out front of the aluminum chloride and a 3 out front of the copper 2 chloride. My coppers are not balanced, so I can come over here and put a 3 in front of my copper and come over here and put a 2 in front of my aluminum. And now we do have a balanced equation. Single replacement, an active metal replacing another metal from a solution. Okay, well, you'll always have in front of you an activity series, and it looks like this. And actually, if you have that handout with you now, you can be looking on as we do this PowerPoint. Lithium is the most active metal, and this series is listed from most active to the least reactive. And down here, we've got silver, platinum, and gold, which are not very reactive metals at all. So anyway, so lithium can replace anything below it in the list. It can also, notice there is a hydrogen on this activity series of metals. Even though hydrogen is not a metal, it can be replaced by a metal. All right, so let's see how this works as well. These really active metals, these group 1A and 2A, the alkaline earth metals, lithium, rubidium, potassium, barium, strontium, calcium, and sodium, they can replace hydrogen from water, even cold water. Then these metals that aren't quite as active, starting with magnesium down here to cadmium, they can replace a hydrogen from steam. So in other words, it has to be heated up. These metals all the way, lithium all the way down to the lead here, can replace a hydrogen from an acid. And then all of these metals down through mercury can react with an oxygen to form oxides. Now again, this activity series will always be provided for you. You don't have to have it memorized. All right, so again, lithium was the most active metal, so it can replace any metal below it on the chart. And remember that hydrogen is on that chart. All right, so let's look at an active metal replacing hydrogen in water. So sodium is one of those reactive metals that can replace the hydrogen from cold water. And so this is water, and I just kind of wrote it funny because our sodium is replacing one of the hydrogens in water. And so I just kind of stuck it out front. So here we go. Single, all right, comes in, replaces the hydrogen, and when hydrogen comes out, hydrogen is one of those 7 diatomic molecules, so you have to write it as H2. And we do know that hydrogen is a gas. And then the sodium is left with the hydroxide ion. Hydroxide is -1, sodium is +1, so it's NaOH, sodium hydroxide. All right, not balanced though. So let's go ahead and give it some coefficients to balance it. Let's see, over here we have 3 hydrogens and over here we only have 2. Let's put a 2 here. Now we have 4 hydrogens on the product side. And if we put a 2 here, we'll have 4 hydrogens as well. And we'll put a 2 here in front of the sodium. And I think that's balanced. Again, an active metal replacing a hydrogen in water. All right, now active metals can replace hydrogen in acids. It's never a good idea to store acids near metals because look what can happen. So here's our metal. It's single all by itself. And here is hydrochloric acid. Hopefully you're learning your acid names. The magnesium can come in, boot the hydrogen out. It's diatomic. It forms H2. Then magnesium comes in and takes its place. But magnesium forms a +2 charge. So we need 2 chlorines to write this ionic compound's formula, MgCl2. Now we can balance it. It looks like a 2 in front of hydrochloric acid will do it. Look what happens if you store metals around acids. If you had a spill, you'd produce hydrogen gas, and that's flammable. That could be dangerous. All right, now let's talk about the nonmetals, and the only ones we're concerned about are the halogens at this point. And fluorine is the most active halogen. And remember, the halogens are diatomic when they're by themselves. And then chlorine is the next active halogen, followed by bromine, and then iodine is the least active of the halogens. And so they're, the way they're arranged on the periodic table is the most reactive, fluorine to iodine. All right, chlorine can replace bromine. And notice now, first of all, chlorine is diatomic. Don't forget those diatomics. When they're by themselves, they're diatomic. It comes in and it's not going to replace the sodium. It's not a metal, so it can't take a metal's place. It's a halogen, a nonmetal, and it's going to replace the nonmetal's place. And so the bromine comes out. Again, it is diatomic, so it's Br2 over here. Now, chlorine is not diatomic when it's combined with something. When it's combined with something, it has a -1 charge, and sodium has a +1 charge. And so we're just going to write NaCl. Again, this is not balanced, so to balance it, it looks like we're going to need a 2 here and a 2 here. And now it is balanced. All right, that is a single replacement reaction where a halogen replaces another halogen. Now, what if we had something like, oh, let's say we had iodine, and we're going to put it in a solution of sodium chloride. All right, so this is a solution. Notice that iodine on our activity series is less active than chlorine. So iodine is less active than chlorine. It can't replace it. So we would say that there is no reaction. All right, and that's perfectly fine. I just wanted to review the halogens with you with some pictures here because we're not going to be doing a lab with these. They're very toxic. Fluorine gas is a clear colorless gas at room temperature. Chlorine gas at room temperature, it is a gas. It's a yellowish green color. It's a really pale color. Bromine at room temperature is an amber liquid. And here is iodine. It's a purple solid, and it sublimates at room temperature. It goes right from a solid into a gas and forms that really pretty purple vapor there. I just wanted to remind you of some of the properties of the halogens. All right, well, let's practice again with the halogen. Here's good old fluorine gas, F2, and it's going to be bubbled into a solution of sodium bromide. Fluorine is more reactive than bromine, and so yes, it can replace it. So fluorine comes in and it kicks bromine out. Bromine is diatomic, and the sodium and the fluoride combine, and now we just have to balance it. For some reason, students don't always recognize this as a single replacement reaction, or they'll try to replace the sodium with the fluorine. Remember, the fluorine is a nonmetal, and it's going to replace the nonmetal bromine. All right, so let's just practice writing a few more equations. Let's remember, you don't need to memorize the activity series. It'll always be in front of you. Remember those diatomic molecules. So let's go ahead and review them now. When these are alone by themselves, so hydrogen, we've got nitrogen and oxygen and fluorine, chlorine, bromine, and iodine. There are 7 of them. If they're ever single or by themselves, they're diatomic. And don't forget to write them as diatomics. All right, so let's go ahead and say that we have got some copper metal, and we're putting it into a solution of silver nitrate. All right, and here's the copper. If we look at the activity series, copper is more reactive than silver, so it can indeed replace the silver. Okay, it's a metal replacing a metal, and so out goes the silver. And then copper is going to form the +2 ion when it combines with the nitrate, and so it's going to be copper 2 nitrate. And then we balance it. All right, what happens if we were to put silver into a solution of magnesium nitrate? So we've got some very nice silver metal. And then we're trying to replace the magnesium. Well, if we look at the activity series, silver is below magnesium. Silver is less active than magnesium. So that's why the activity series is important. This reaction will not happen. So you have to consult your activity series to see if a reaction will happen. And silver cannot replace magnesium because it's less reactive. All right, and then let's do one final one. Let's put some chlorine, and that would be a gas. Diatomic, chlorine is diatomic when it's by itself. And let's put it into a solution of potassium iodide. Chlorine is more reactive than iodine, so it can come in, replace the iodine, I2 plus KCl, potassium chloride. And when the potassium combined with the chlorine, it's just 1 chlorine. Now we balance with our coefficients out front. All right, well, we've done a lab on this. We've created our own activity series, and you had a lot of practice writing those reactions. And so I hope you can recognize single replacement reactions and understand how to use the activity series. Bye.